So we said for conditional probability, Zach, what we're doing is we're going backwards up the tree. We're going backwards up the tree. So as an example here, we had a tree. We said 70% of the items came from factory 1, 30% from factory 2, and then they could be defective or not. And I said, what's the probability the chip is defective? Okay, that's asking you to tell me something from the bottom. That's multiply down, add across. But in part B, I said, okay, what if you know which of the bottom branches were on? Defective. What's the probability that it came from factory 1? Tell me what the probability is of which branch we came down from the top. We're going backwards. And what I told you as a formula, the way I've always handled this, Pam, is I translate it this time into symbology, but then it's always both and on the top, one and defective, divided by the given one, the second one, the defective one. Let's try another one. So here's where we said pause here. Card question from our big notes. Turning the page. Says this: a card is drawn from a shuffled deck of 52 cards and not replaced. Then a second card is drawn. How many cards are we picking? So how many cards are we picking? Tree. Tree. A asks, what's the probability that the second card drawn is a king? All right, here's our tree. What are the events? The second card being a king, it depends. Do you know what it depends on? First card's a king. So my tree is going to look like this. King 1, not king 1. King on the first or not. King on the second or not. King on the second or not. Let's fill in the values. Let's weight the branches. How many kings are in the deck? Out of? So on this branch, it's going to be 4 out of 52. What about on the branch across from it? 48. And I heard somebody say compliment. I like that. I give you a compliment for saying compliment. Let me compliment your compliment. Down the left-hand branch, Brianna, we got a king. So how many kings are left in the deck now? 3 out of 51. What's the one across from it going to be? I'll give you a hint. Still out of 51. How many non-kings are left in the deck? 47 or 48? Jordan. Also, what's your built-in error check? These two here should add to 51 out of 51. They should add to 1. And yeah, by the way, I almost wish we would teach this in grade 8 and 9. Wouldn't you be better at fractions by doing it this way instead of just doing them anyways? Because these are interesting fractions in my mind, not crummy fractions. Down the right-hand branch, Taylor, we picked a non-king. How many kings are left in the deck then? How many kings are left in the deck? What's going to go right here? 4, right? Out of? How many non-kings? Because we didn't get a king on the first, so there's only 47 left. There's my tree. Logan, what's A asking? Can you read it to me, my friend? You know what? I think we're talking about K2. Look at my tree. This is not conditional because K2 is on the bottom row. In fact, doesn't K2 appear twice? You see it, Logan? 2 branches. You know what? Multiply down, add across. It's going to be the left-hand branch or the third branch. First branch or third branch. First branch is 4 out of 52 and 3 out of 51. Right? That's that branch. Or that branch. 4 48 out of 52 and 4 out of 51, which is what? Do you get 1 out of 13? Yeah. I have some of these fractions memorized because I've taught the card questions so often, so I took some shortcuts there. But you should get 1 out of 13, yeah? Okay. Darian, is that okay, or you made a typo? Okay. Alyssa, can you read B to me? Stop. That's going to be the trigger word on your test that I'm going to try and use consistently. That probably says be alert for a conditional. Now, if it's a conditional, here's what it's going to say. They're going to give me something from the bottom row of the tree, something about the second card, and they're going to ask me something about the top row, the first card. Read to me the whole thing again. Told you, bottom row. Keep going. To answer this, we're going backwards up the tree. I'm going to use the conditional probability equation from your formula sheet. And the way I've told you to remember it, because it's all confusing letters, is start out by translating this. P bracket space, and then there's my given bar. What's given? What did they tell me? Sorry? They told... This is important. You cannot make that mistake. What did they tell me? That's the given K2. Find what? Just find what? Not K1. If I can get that, Brianna, do you see where it came from? Got to go step by step. Then here is the answer. It's going to be both and over the given one. Now, what's both not king 1 and king 2? What we're really talking about, Taylor, is that branch there. It's going to be 48 over 52 and times 4 out of 51. The top of this fraction is going to be 48 out of 52 and 4 out of 51. There's the first part of what's often called Bayes' law, or conditional probability. What's going to go on the bottom? King 2. Put your pencil down. King 2 is this branch or that branch. Don't write this down yet. It's 4 out of 52 and 3 out of 51, or 48 out of 52 and 4 out of 51. Don't write that down yet. First of all, do you notice that this appears down there somewhere? That's kind of a built-in error check. These don't cancel. You cannot cancel. The reason I said don't write that down yet is, didn't we actually figure out what that is right here? So although in my notes I've showed you that we could have, if I hadn't done part A, I could still do part B by just filling in those two branches. What I am going to say to write down is, hey, 1 over 13. It's less work. Is that okay, Grayson? But if you're doing it all from scratch, a nice built-in error check. What's on top did appear somewhere in the bottom. Don't cancel it. Now, how the heck do I type that in? I guess I better go to my Casio calculator. Is there more than one number on the top? I might want to put those two fractions in brackets. Maybe I don't need to, but better safe than sorry. So bracket 48, fraction button 50. And again, if you haven't figured out your fraction button, please figure out your fraction button. You notice I'm not going divided by for fractions. And for fraction 51, now I'm going divided by, because that's a great big divided by line. 1 fraction 13. And you get 16 out of 17. Or 0.9411. By the way, you all know F to D, fraction to decimal, right next to it. So you can flip-flop back and forth. But I'll say 16 out of... You know what? If you got a king on the second card, there's a 16 out of 17 chance that your first card was not a king. That's useful information. But you can see we're going backwards up the tree. C. C. No yawning. Carson, can you read? You know that was coming. Can you read C to me, please?
What is the probability that the second card is on its face?
You know what? I think I'm going to have to do a tree. And you know what? The second card being a face card depends. You know what it depends on? Whether the first card was a face card or not. I got to be more specific, not just what the first card, whether it was a face card or not. So it's going to be F1, not F1, F2, not. There's my tree. I'm going to do it kind of right here. Did I leave? You know what? I'm going to do it down here. I got more room. So F1, not F1, F2, not F2, F2. By the way, some of you have told me I have trouble figuring out what the tree is supposed to look like, which is why I'm saying, hey, it depends. I'm trying to walk you through how I figure out, Sterling, what the branches are going to be. Face cards, what are those? How many Jack, Queen, Kings are? 3 times how many suits are there? 4. How many Jack, Queen, how many face cards are there in the deck? Out of? So it's going to be 12 out of 52. How many non-face cards? Down this branch, we picked a face card. So how many are left? 11 out of 51. How many non-face cards? 40 out of 51. Down the right-hand branch, I didn't get a face card. So how many are left? 12 out of 51. And, whoop, 39 out of 51. Again, are these two branches identical to those two branches? Everybody say no. That tells you these are not independent. These are dependent. That's still, I gave you the mathematical definition back in that lesson, but to me, Chelsea, the easiest, I look at the tree, and if the branches don't match, oh, it depends which branch you go down, apparently. So far, so good? All right, let's answer part C. Second card drawn is a face card. That's 2 branches. See it? 2 branches end in F2. It's going to be, hey, why don't you try it? I'll do it up here. Let's see if we get the same thing. It's going to be sorry. Did I type that right? That and that, or that and that. No? Am I right? Yeah? Okay. Okay. Rachel, can you read D to me?
What is the probability that the first card was a face card?
Stop. What are they asking me to find? The probability that what?
First card.
Hey, that's this row. You know what? I'm already thinking this might be conditional because they're asking me to find something up here, not at the bottom. Keep reading. Given, there's my trigger word for conditional. Yep.
The second card was not a face card.
We have to translate this. And then it's going to be both and divided by the given one. What did they give me? What's the given one? Be very careful, but what did they tell me? So we have not F2. What do they want me to find?
F1.
And I'm telling you, it's going to be both and, whichever column has F1 and F2 not F2, should say that properly, divided by F2 not, the given one. Okay. I'm going to have to move down here. That's okay. Both and. So F1, 12 out of 52, and not F2, that's the 40 out of 51. That's the branch I want, right? Over. By the way, what did I find in part C? Can I use that to figure out the probability that the second card drawn is not a face card? How? More specific. Really? 10 out of 10 out of 13. By the way, or what I could do underneath there is any branch that ended in not F2. I could have that one or that one, and that's perfectly acceptable. Yeah. Is what 40 out of 52? Here? What's that? Read it to me. Look up, look up, look up. Here. And what's the next thing? What's the next thing here? Not this branch, because I'm saying go down here and that. Not that. Here and here. This is the branch that has them both. You see that? And yeah, it's easy to get the numbers mixed up. But you see, it has to be 51. Is that okay? Is that okay? And you okay with our clever saying, hey, the bottom is going to be 10 out of 13 once, Dom figured it out? Okay. What's the answer? And again, if you're not practicing typing these into your calculator, you're setting yourself up for ugliness because it's not as simple as you might think. 4 over 17. Anybody else?
Got the same.
Okay. The homework is eventually going to be a handout, but I have to do some cool ones. I promised you that I would maybe save your life and also give you some legal advice. Can you look at the single page handout that I gave you that says more examples? By the way, about 2 years ago, a study was done asking doctors whether they knew this, and I think it was something like 70% of the doctors did not know this and were giving terrible medical advice. So here's the question, and I'm going to be serious for a bit. Let's suppose it's known that 3% of the population suffer from a certain disease. Hey, let's even say some rare form of terminal cancer. Let's go really serious. Something that's going to kill you. There's a test for that disease, and it's 95% accurate. A person goes to the doctor, they take the test, and they test positive. What's the probability that they have the disease? Many doctors will say, well, the test is 95% accurate, and so there's a 95% chance that they have the disease. And they are wrong. They are terribly, tragically wrong. This is a job for conditional probability. There are two situations here. You have the disease, or you know what? Let's use D for disease. What would be a good letter to use for testing positive? P. Those are going to be the two events on my tree. The question is, which one's going to be on the top level? Which one's going to be on the bottom level? What happens first? Do you have the disease first, or do you test positive first? I think before you come to the doctor's office, you what? So we're going to have our tree is going to look like this. Disease or not. And then test positive or not. Test positive or not. You with me so far? What's the probability that a random person has the disease? What percent of the population has it? So I'm going to go 0.03 because I got to change it to a decimal. By the way, what's the probability that a random person doesn't have the disease then? This is a job for the complement. 0.97. Now, let's go down the disease branch. If you have the disease, should you test positive or negative if you have it? Positive. How often? How accurate is this test? Okay? 5% of the time the test will miss it. And that happens. There's no such thing as a perfect medical test. We call that a false negative. If you don't have the disease, right-hand branch, should you test positive or negative? Negative. How often? How accurate is this test? 0.95 goes on the negative. How often should we have a false positive? 5% of the time. There's our tree. All medical tests have false positives and false negatives. Now, let's translate the statement, the second sentence. Matt, can you read to me the second sentence, please? There's my conditional. Okay, here we go, here we go, here we go. I want to find the probability, given what? Oh, given that. Keep going. Can you read it in a slightly louder voice? I got that. Comma, after the comma.
What is the probability that they actually have it?
Oh, that. Again, I've made up numbers for this test, but when this was presented to doctors, a large number of doctors said, oh, there's a 95% chance this person's going to die. Which, to tell that to a patient when you're wrong is terrible. This is we're going backwards up the tree. This is conditional probability, so it's going to be both. And again, Alyssa, by both, I mean that branch there, 0.03 times 0.95. Over the given one, any branch that ends in a P, which is both of those. The bottom of the fraction is going to be 0.03 times 0.95 or 0.97 times 0.05. Is there more than one term on the bottom? Put the bottom in brackets. Crunch the numbers and get a very surprising answer. This test is apparently 95% accurate, and you've tested positive for a terminal disease. What's the probability that you actually have it? It ain't 95%. It ain't 90%. It ain't 85%. What'd you get? 37%. Is that what you got? Give me the whole thing. 37 point what? 37.1, so 0.01%. You've got actually a 2 in 3 chance, Brianna, of being healthy. And here is the horrible, horrible thing. There are many documented cases of people being told they tested positive for something terminal, and rather than go through the horrible dread of going through the disease, they take their lives. They commit suicide. And doctors don't realize. So my message for all of you, if you ever get bad, oh, and by the way, most medical tests are not 95% accurate. They're way worse. If you ever get bad medical news, take and demand a second test. Please. Please. Now, if we were to extend this tree one more level and run this through 2 consecutive positives, then it gets around 80 or 85% if you test positive twice, and then it's much more serious. Also, though, in terms of celebrity gossip, if you hear of celebrity X testing positive for drugs or athlete X testing positive for a banned substance, wait until you hear the results of the second test. That's a staggering number to me. Kind of cool. Okay.
Can you show us how you did it on the calculator?
Oh, sure thing. I hit clear. The top, is there any plus signs on the top? It's all being multiplied. I can just type the top. My calculator won't, like that. Divided by, are there plus signs on the bottom? I have to put it in brackets. Now look up. When I type on a calculator, I don't use brackets for times. I use the times. I would type it like this. 0.03 times 0.95 plus 0.97 times 0.05. Because that's easier for me to see what's on the top and what's on the bottom. And there's your 37.01%. Okay? Physics kids, we've been through this many times before, but yeah, your calculators, you have to understand how they work. Turns out, this is also why you can't use lie detectors in the court of law. So, Tiffany has been accused of a crime, and to clear her name, she volunteers to take a polygraph test. From previous studies, we know that in a polygraph test, people tell the truth 98% of the time. Tiffany fails the test. This test is 96% accurate. Surely that means there's a 96% chance that she's lying, right? By the way, this is why don't take polygraph tests if you're ever off. And this is like there are corporations that use polygraph tests, the CIA, NSA, to like weed out employees. This is terrible, terrible. Okay. Do you lie before you take the test, or do you take the test and then lie? I think here it's going to be lie or not lie, fail the test, not fail the test. I think our branch is going to have, what would be a good letter to use for truth? Okay. What would be a good letter to use for failing a test? F for fail? Okay. So Tiffany takes this test. She can be telling the truth or not. From previous studies, and there are many of them out there, we know what's the probability that she's telling the truth? 0.98. What's the probability that she's going to get away with a fib? Okay. By the way, if you haven't seen the Seinfeld episode where Jerry tries to pass the polygraph, right? You have the classic George Costanza, who's the ultimate liar. What's his line? Jerry, it's not a lie if... This is his advice to Jerry. It's not a lie if you believe it.
Yeah.
That's how George is able to lie so well, right? Self-delusional. Okay. You can fail or pass, not fail. Fail or pass, not fail. Now, down this here, you're telling the truth. So should you fail a test or pass the test? How often? 96% of the time. What percent should you fail a test? Down here, you're lying. So should you fail a test or pass the test? How often? How accurate is this test? 96%. And there's George Costanza. He can lie and he won't get caught. All right, now let's translate the statement. Given what?
That she fails.
Find what?
Not true.
Which is going to be both over the given one. Which branch has both not true and F? 0.02 and 0.96 over. Which branches end in F? Two of them. 0.98, 0.04, or 0.02, 0.96. Also, remember I said as a built-in error check, often what's on top will appear on the bottom. It did, so I kind of have a little nerdy smile. What's the probability that she's actually lying if she flunks the test? By the way, it's not 96%. It's not going to be 90%. What? Oh, you're just guessing. What'd you get? Same idea as before, Taylor, and I'm deliberately not doing it on my calculator to force you to struggle through it, but brackets around the bottom, right?
25.51.
Anyone else? 0.2551? 0.32?
I got 0.32.
Okay, by the way, if you're getting the wrong answer, you need to talk to me and figure out how to use your calculator. So you ready? Mackenzie, 0.02 times 0.96 on the top, right? Divided by bracket, 0.98 times 0.04 or 0.02 times 0.96. Right? Brianna, look over her shoulder because you'll spot a typo faster than she will because we don't see our own mistakes. There you go. Yeah. Oh, 0.04? No. Don't clear your. Hang on. Don't clear your screen. Don't touch anything. Let me pause the video. 32.9%. Yes.
Yeah.
By the way, listen up, please. That's the probability that she's lying. What's the probability that she's telling the truth? The complement of that. 60, basically a 67% chance. And the big issue I have here, we have major companies, and especially since 9/11, that are using polygraphs on employees to get them fired. And so as young political activists, if you hear that starting to happen in Canada, there's no such thing as a polygraph that's 100% accurate. Numbers don't mean what people think they mean. By the way, the reason these are both so skewed is there's a lot of people that will tell the truth on an inaccurate polygraph. And even if the polygraph is only 4% inaccurate, 96% accurate, you'll get a bunch of people in there telling the truth, and that'll show up in your sample. Got one more, and we're done. Oh, by the way, for Ben and for all of you, hey, I really, really like example 4. I really, really like example 5. And I really, really like example 6.
Do we expect all three on the test?
Not all 3, but at least one of those 3 somewhere. Maybe 2 of those 3.
Okay.
First of all, hey, come on, those first 2, those are some neat applications. This one here is just good practice. So instead of cards, let's go marbles. Let's lose our marbles. Jar A contains 4 black and 2 white marbles. Jar B contains 4 black and 8 white marbles. We're going to pick a jar at random, and then we're going to select a marble from the jar. A says, what's the probability that it's black? And B says, given, I hear a conditional. We'll tackle that next. What 2 events are there on my tree? I'll give you a hint. One of them is picking a marble, but there's something else we have to do first. Pick a jar. Pick a jar. Okay? So we're going to have jar A. Now, I got a bit of a problem here. What's the other jar called? B. And what colors have I used? White and? Black. I'd love to use B for black and W for white, so I'm going to go jar A and jar not A. Otherwise, I'm scared I might get them mixed up. What's the probability that I pick jar A? How many jars are there? Now, it's going to be then, I can change that. I could instead maybe have you roll a dice, and if you get a 1 or a 2, you pick jar 1. If you get a 3, 4, 5, or 6, you pick the second jar. That would be 2 out of 6, 4 out of 6. In fact, I might do that on the test just to make it a little more interesting, because 1/2 and 1/2, Brianna's kind of boring. What's the second event? Pick a marble. In jar A, what are my possibilities? White or black? By the way, in jar A, what's the probability that I get a white marble? 2 out of 6. 4 out of 6. In jar B, I can get white or black. Okay. In jar B, what's the probability to get a white marble? I'll give you a hint. 8 out of 12. 4 out of 12. Are these dependent or independent? These are dependent. It depends which. By the way, what we're really saying is, yeah, it depends which branch you go down because the odds change, the fractions change. All right. What's A want?
What is the probability that it is black?
You know what? That's here or here. By the way, what it's really saying, if I wanted to write this as a formula, don't write this down. The probability that it's black is going to be the probability that we're black given that we went down jar A and that we're black given that we went down jar B. You know what? It's much easier to get it from the tree. It's the two branches that end in black. It's going to be what? A half times 4 out of 6 or a half times 4 out of 12. It's going to be 4 out of 12 plus 4 out of 24, which is 6 out of 12. Is it 1/2? Yeah. Even? That's a nice fluke. Oscar, that 1/2 has nothing to do with the 1/2s on the jar. That's just a fluke. Oscar, can you read B to me, my friend? Given. Okay. Conditional probability. I think, especially if the given is the bottom row. Keep reading. Given what?
Given that the marble is white.
Okay. They gave me something from the bottom row. Are they asking me something from the upper row?
No.
What are they asking me to find?
That came from jar B.
Isn't the upper row which jar? So are they asking me something from the upper row? Say yes.
Yes.
Thank you. We have to translate it to get the formula right. What's the given?
The marble is white.
W. What do they want me to find?
The probability that came from jar B.
Which I wrote as not A because I didn't want to have B's everywhere. And you know what it's going to be? It's going to be both over the given one. What do I mean by both? The branch that has both. What do I mean by the given one? The branches that end with a W. So it's not quite plug and chug, but kinda. Once you get to this line, it's going to be which branch has not A and W. You know what? It's going to be 1/2 and 8 out of 12. It's going to be that branch. Over white. By the way, I could probably use the complement. I think the probability, if the probability that's black is 1/2, I think the probability that's white is also 1/2. But just to show you, if I hadn't done that, I could still find it. It would be 1/2 2/6 or 1/2 8/12. And there's that built-in error check. You notice how the top showed up somewhere in the bottom? No, they don't cancel. Which is what? 5 over?
9.
Anybody else? 2 out of 3?
5 over 9.
I've heard 2 out of 3. I've heard 5 out of 9.
I'm going to do over 3.
Let's see. It's going to be on the top. I'll put it in brackets just to be paranoid. 1/2 and 8/12 over 1/2 and 2/6 or 1/2 and 8/12. 2 out of 3. You have to. There's more than one number on the bottom. Because your calculator, if you don't put brackets, will assume you want everything on the top. You have to tell it. As soon as you do a plus sign, it assumes, oh, you want this over here on the top. They're stupid. So if there's more than one thing with a plus sign on the bottom, got to put it in brackets. Oh, and if there's more than one thing with a plus sign on the top, got to put it in brackets. 2 out of 3. Put your pencils down.